Okay, so let's now look at the remainder theorem. This is connected to the factor theorem, and as we'll see, which of course we need to be able to divide polynomials. If we took, let's take an example. So this function is x cubed plus 3x squared plus 4x plus 1. Now let's say we're going to divide this by x minus 1. We don't know yet if it's a factor. We could, of course, substitute in, or we could say f of 1 using the factor theorem and see what happens. But let's just divide first of all, because I want to show you something slightly different here, another idea. So if we divide by x minus 1, so we're going to divide this function by x minus 1. X into x cubed goes x squared. But if you're having any difficulties with that, this is a nice way to represent it, because you can see here that this would be x squared. So it's x squared. X squared times x is x cubed. X squared times minus 1 is minus x squared. And if I take that away, of course I'm going to get 0 here. Plus 3x squared minus x squared, which gives me 4x squared. So how many x's in 4x squared? Well, that would be plus 4x. And we can always check here. We want to divide 4x squared by x, and that would give us 4x. So the x is in 4x, or sorry, x times 4x, which is 4x squared, minus 1 times 4x, which is minus 4x. Take that away. So I want plus 4x minus 4x, and I end up with 8x. So then I would say how many x's in 8x. So this is a repeated move. That's why I call this a dance. It's a repeated move. How many x's in 8x? And we would get plus 8. So therefore 8 times x is 8x. Minus 1 times 8 is minus 8. And if I take that away, plus 1 minus 8 is 9. So I've got a remainder of 9. So this is my remainder. So we could say that this function, x cubed plus 3x squared x plus 1 divided by x minus 1 is the same as x squared plus 4x plus 8 here with a remainder of 9. So I still need to divide that 9 by x minus 1. So my remainder is 9 divided by x minus 1. Yeah. Okay, so we could also then get rid of this x minus 1 on both sides, and we could end up with x cubed plus 3x squared plus 1 is the same as x minus 1 multiplied by x squared plus 4x plus 8 plus 9. And here we've got our, look, remember this is the quotient. This is the answer we get when we divide. It's also called the quotient. We've got our remainder here, what we said. And so we've got some function f of x is the same as x minus 1 multiplied by this other function, the quotient. We're going to call that g of x plus 9. Now, if I substitute in value of 1 here, this here is going to equal 0. So no matter what this quotient is, what we get when we divide, remember, multiplying it by 0 will equal 0. So I get f of 1 will equal, okay, let's write out for 1 minus 1 times this g of x plus 9, which equals 0 multiplied by g of x plus 9, which would equal 9. Okay, so what we're saying is, if we substitute in this value, do you remember from the factor theorem we had x minus a? If we substitute in f of a into here, we're going to have what's left over. If it's not 0, if it's 0, obviously, if f of a equals 0, then we know that it's a factor. Then we know that we know that x minus a is a factor. But if it's a non-zero value, so if f of a is a non-zero value, then what we'll get is we'll get 0 multiplied by the quotient g of x plus some constant k, which is the remainder. So in other words, if we put in some value of a and it's non-zero, that is the remainder. So the remainder k is f of a.